Good morning. Welcome to the first session of the last day of the summit. Today, in this session, we'll be talking about how to set up and run a Spark job in Kubernetes, but accessing data in HDFS. Specifically, I'll talk about a setup which typically you get in a corporate environment, which means it has to be secured. The content that I will present and all the patterns that I will try to cover as much as I can be applied to any elastic compute cluster and any kind of distributed storage. It's not specifically to Kubernetes or HDFS, but you can apply to any other compute cluster like Eon or Mesos and a storage as maybe S3. My name is Joy Chakraborty. I design and write software for a living. Most of my recent project involves designing and building distributed compute and storage system for doing various kind of activities such as data analysis, data science, including machine learning. Just want to make sure that the technology that I'll be covering, I'll just scratch the surface, so because we don't have enough time to go into the details. So here is the little agenda. We'll be talking about Kubernetes as elastic compute, HDFS as a secure distributed storage. We'll see how to configure Spark to run in Kubernetes accessing HDFS. And then finally, I'll keep some time to give you a live demo if time permits. I did enough practice, I hope. We'll have some time for demo. So let's start with why Kubernetes. There are a few reasons, and honestly speaking, it doesn't have to be Kubernetes. It could be something similar. The reason that we are talking about Kubernetes today because it's one of the popular one now, and this is highly portable, which means kind of you can port whatever you set up in your local machines or laptop to a dev or prod cluster on-prem or to the cloud. So what actually we need is a compute environment that supports elasticity, which means it can perform various kind of workloads, such as CPU, GPU, to process massive amount of data in a secure, reliable, and predictable way. So in any organization, security, reliability, predictability is very important. For a lot of the use cases, GPU also becoming essential, so we cannot ignore it anymore. But at the same time, we have to remember the end user who are using these systems should have an easy and consistent access pattern. I have seen in my experience that there are so many things in the market people are using, and the end user get confused which one to use and how to use it. So in a corporate environment, we always end up with multiple systems. But as an engineers, our job is to provide a consistent access pattern and abstract away the system level variances as much as possible. The next thing is it has to be distributed and containerized. The reason that containerized solution provides a good isolation and a lot of reusability, which is very important. Some of the characteristics of such systems should be to provide a kind of a management capability to maintain the containers, because it's a containerized solution, and various kind of resources such as CPU, network, your memory, storage. And the other important part is the scheduling. Scheduling has to be part of such kind of a system. And Kubernetes does provide these capabilities that we just talked about in the last few slides. And Spark now supports running in Kubernetes in 2.3. So it's a good time to catch up and see how we can run Spark in Kubernetes to build an elastic compute cluster. One point to be noted, our goal should be to run Spark the same way it runs in Eon or Mesos without changing the access pattern again, because to be consistent. And the good news is we can do it. So we'll see for the rest of the presentations how to do it. Let's talk a little bit about Kubernetes. This is not a Kubernetes talk, but I just want to make sure that we are all in the same page and have a common understanding for the rest of the presentation. Regarding Spark, I'm not going to go into the basics because I'm assuming that a lot of you know Spark and it is in the industry for a long time. But I will cover a few things here and there throughout the presentation whenever required. Kubernetes is an open source container and resource management system. It is very modular in design. It's very much extensible, and extensibility is one of the reasons why Kubernetes is so popular today. We'll see some of that. The latest release is 1.8.14. It is written in Golang. It is highly community driven. So you can contribute if you are interested in Kubernetes. I actually do contribute to Kubernetes and Spark. Now, a little bit on the high-level architecture of Kubernetes. It has a master node, which is responsible for running most of the central services, such as API server. API servers is important because the end user, you are going to talk to the Kubernetes cluster through the API server. Also, the master node is responsible for running scheduler and other kind of services. And the rest of the nodes are called slave nodes. And they basically run a process which is known as kubelets, which is basically responsible to maintain the state of the cluster fabric, talk to the other nodes, and to communicate to the master for using the respective services. It's kind of a master-slave architecture, not something kind of new. Now, some of the basic or core components that Kubernetes provides out of the box. Also, you will be dealing with most of these when you are going to use any kind of Kubernetes clusters are. The first one is the namespace. Namespace gives you kind of a work area for a user to create any kind of other resources and run services. So namespace can be used to assign permission or policies. Then the next one, which is the most important one in Kubernetes, is called pod. Pod is a basic unit of compute resource where you will run your compute workload. You can think of this as a container representing a running process that you can get for a given specification that you ask for. The container is built primarily using Docker, but you can use any other kind of container runtime solution. Services, another important one, which gives you the abstraction to deploy and run any long-running job, preferably stateless, and having some endpoints. Volume is the abstraction layer for the storage resource. You can mount any kind of storage, such as HDFS. Some of the other components we are not going to talk much, but this is just for a reference. If you are interested, you can look, and I encourage you to look for, such as replica set, deployment, jobs. There's one more important one, is called RBAC, through which you can actually set up the permission, access rights, and policies. Finally, it's the last but not the least, one of the most important capability that you get in Kubernetes is you can create your own custom resource and deploy it. And when you create a custom resource in Kubernetes, it will be treated as a first-class citizen, which means as an end user, you can create, update, or delete and search the custom resource the same way as you access any kind of other resource out of the box, such as pod. So custom resource is one of the powerful things in Kubernetes. Next, we'll see how to interact with Kubernetes. Primarily, there are two ways you can access Kubernetes. One is using the REST API. And the second one is a command line, which is also called Coopctl. This is kind of a CLI. Now, in order to access Kubernetes cluster, you need the configuration file, which is also known as koopconfig. You normally get it either from the admin, or when you do a local deployment of Kubernetes, it will be created for you during the cluster setup. Now, before we talk on designing a Kubernetes cluster, running Spark job, and accessing data from HDFS, let's see how security or the Kerberization worked in HDFS. Many of you probably know, but this is just a quick recap for completeness. In a Kerberized HDFS setup, you have basically three components: the KDC, which is the Kerberos server, backed by probably Active Directory, the HDFS, and the client. This slide summarizes the Kerberos authentication workflow. It normally starts with HDFS getting authenticated with the KDC. using its service principal and keys. What essentially it means that the HDFS is now trusted for this KDC. And KDC allows the HDFS to authenticate a client using a ticket issued by the same KDC. Then the client requests the KDC for the Kerberos ticket using principal and password or key tab. KDC sends the ticket. Now, the first ticket that KDC sends to the client is going to use this ticket every time it wants to talk to, say, for example, in this case, HDFS. So before talking to HDFS, it will use this ticket and talk to the other part of the KDC, which is called ticket granting service, which is going to give a token for HDFS specific token. And then client is going to use this token to communicate to HDFS name node. And once HDFS name nodes authenticates you, then the connection is established between client and HDFS. That's kind of how the Kerberos works, not only with HDFS, with any system that uses Kerberos. But wait, there is a little variation to it. So key tab is not the only option. There is other option also you can use, which is called delegation token. A lot of time people use it. In this case, most of the steps remain same. Only the last two steps are different. What happens is, once the client gets the second ticket, it is going to use this ticket and ask for a token from the name node. And for the rest of the communication, the client is going to use the delegation token, and that's going to avoid a lot of the load to the KDC. Now, the delegation token is very popular in those scenarios where you do a lot of kind of back-end service, talking to each other very frequently, because every time you don't want to hit KDC. And delegation token has some kind of an expiration date and time, so it is also secured in that way from a policy perspective. Whereas if you want to use a key tab is kind of, I have seen in most of the organization forever, people use it, unless you lost. Okay, so now let's see how to design the Kubernetes cluster running Spark job, accessing data from HDFS by combining all this technology. One point I would like to highlight: traditionally, we run Spark job using Spark submit, which is very well known. And in Kubernetes, we will submit the Spark job using the same Spark submit command. So there is no difference, because the Spark starting 2.3 does support Kubernetes to do the Spark submit and use a Kubernetes as its resource manager. And this is good because, again, it is consistent with Yarn or Mesos. So we start with the Kubernetes cluster, having a master node which is running. Now the client comes, and the client wants to do a Spark submit. The only difference over here, which I highlighted in yellow on the left-hand side, is that when you are submitting a Spark job to the Kubernetes, one of the changes that you have to make is your master URL is going to be a different. Instead of Yarn, you are going to specify a Kubernetes master URL, which starts with a K8s. That's kind of the protocol. Kubernetes masters are then going to create the driver and the worker pods. Make sure who are not familiar with Kubernetes, think of every time I use the word pod, which means think of as a container. So Kubernetes master is going to create this based on your need. You might say that I need 4 workers, so it's going to create 4 workers pod. Now, in order to create that pod, Kubernetes needs something which is called a Docker image, because these containers need some image. So in this case, Kubernetes is going to talk to your Docker hub or the Docker repository to get an image, and that you can pass in the Spark submit command. There is a new option which is called image, and you can set up the image location and the name. And this is also not something specific to Spark. Every time you create any kind of a pod in Kubernetes, it will ask for that image. Now, you have your Spark job driver and the workers up and running. Now they want to talk to HDFS. Now, in order to talk to HDFS, as we have seen, you need a key tab or delegation token, correct? So Kubernetes has another kind of resource which is called secret. Now, this secret is something similar to Docker Swarm if people are using it currently. So you can store your key tab or any kind of a password or something inside your secret which is specific to your namespace. And you can only allow to read or change. Nobody else can see it because everything is hierarchical in Kubernetes. So all the pods that you are running is inside your namespace. And secret is also in your namespace. Now what the secret does, it allows you to mount the secret to the pod inside the container, just like a KeyTab file. And then the worker pod or the driver pod, whoever needs to talk to HDFS, can actually use it just like a regular KeyTab file. So this is how, in a nutshell, you are going to design the Kubernetes cluster, which is going to talk to HDFS. So you basically need a Docker hub or repository to get access to the Docker image. You probably need a secret in most of the organization because your HDFS is Kerberized. And you need to have a Spark client installed to do the Spark submit. That's all. So now, let's build the Kubernetes Spark HDFS environment and see how to build one of such. Now, before I'm going to go into these details, what to use, I just want to revisit our objectives. We want to build an environment, and I strongly believe in that as a developer or as a software engineer, I should be able to do everything that you have seen in the last slide, that complicated slide, all the arrows, in your local machine, means in your laptop, maybe on your desktop. And when you are happy with your code and your software development, you should be able to port all the artifacts to the next level, which could be your dev cluster or QA cluster. And then when you are done with your testing, happy, move it to prod. Your prod could be a cloud. And so that's why Kubernetes is highly portable. What all the artifacts that you are building in Kubernetes can be shipped. Now, one thing that I didn't mention in any one of the slides, when you create an artifact in Kubernetes, basically you are creating few things. You are creating some Docker images, which the pods are going to use, and then you are going to create some of the resources, which normally represents in a YAML. So you have just the YAML file, and you have the Docker images, and just that you need to ship wherever you want to deploy. You can use any kind of scripting language to ship it. But over here in these slides, what I'm showing today you how to set up such thing. So the first thing is how to install Kubernetes in my laptop. And by the way, I'm now going to give the demo. Everything I'm going to run is everything in this 12-inch MacBook small laptop. So it's not a very powerful machine either. So there are so many different ways you can install Kubernetes in your local machines. One of the popular way is you can use a Vagrant KubeVM. There are many such open source GitHub projects. You can take one of that, or you can use the one that I'm using, which I provide a link over here. So what essentially you need is a Vagrant and any kind of a VM software over here. Now, once you install Kubernetes, because if you just run this script, you just do a git clone, you have the Vagrant, you resolve all the dependencies, run the scripts, boom. And you can specify how many nodes you are going to create. It will create a Kubernetes cluster. Then, in order to run everything in a local, you need to also have some kind of a Docker repository, right? So I install the standard Docker registry container, which is also running in a Docker, so that I can push and pull my images. Then in order to run a Spark submit, you just need to install the Spark client, and that's all you need. So so the important components are, again, you need to have a Kubernetes install. You can use Vagrant and any kind of VM technology that you are familiar with. You need a Docker, and you need a Spark to be installed. So now, let me switch over to the other screen so that I can give you the demo. OK, so first thing first, I am going to show you that I'm running a cluster over here using Vagrant. OK, so I'm running a 4-node cluster. And Kubernetes is installed using VirtualBox. You can use something else. So I have 1 master and 3 slaves. Now, I'm going to use the command line. just to see the cluster information. You can see that my master is running at that address. So why I'm showing it? Why is it important? The important is when I'm going to do the Spark submit, I'm going to use this URL. Next, let's see what I have. So you can see I have one Docker container running. This is basically the Docker registry, which is working as a Docker hub. And I'm going to use this Spark Docker image. Now, if you go to the Internet Docker Hub, you should be able to pull, but just make sure that you are using Spark 2.3, because since 2.3, they started supporting Kubernetes. Then, let's look into a few of the commands in Kubernetes that I was talking about. So Coopctl is the command line interface for Kubernetes. I want to see how many pods I have. I can just do get pods. Currently, there is no pod is over there, but by default, when you do anything in Kubernetes, is everything it gets from a namespace which is called default. Now, I can specify any specific namespace, or I can say, show me everything in all namespaces. Of course, I'm admin in this case, so this is why I'm able to see. You see that there are some other system-level namespace where a bunch of things are running, which I'm not interested for this part of the presentation. So you have seen that we can set up this cluster, so that's all I need. Now the next thing is, I'll just go over that. So I'm going to use a Spark submit to run a job. Now, because for this part of the presentation, the nature of the job is not important. It's just to show you how to do it. So what I'm going to do is I'm going to use one of the Spark sample pi. Basically, it calculates pi in a distributed fashion. So the difference over here you can see is the master URL, which I just showed you before. So this is the Kubernetes URL that I'm using instead of a yarn. Deploy mode is cluster. One point to be noted that today the Spark on Kubernetes only support the cluster mode, not the client mode. And I believe in any corporate environment, you will probably never run a production level job in a client mode. Probably will run it anyway in the cluster mode, but still. For your testing purpose, you should be able to do the client, but currently they don't support it. And the only other change is over here, which is a new configuration parameter, Kubernetes container image. I'm giving the kind of the image URL in this case, which is running in my local machines in a Docker container. And that's all. No other changes. I'm trying to use a minimum resources because I don't need much to run a Pi. So what I'm going to do is I'm going to copy. Let me go to some window, and I'm going to submit this job. Now, as I'm submitting this job, let's see what is happening in Kubernetes. Kubernetes has a command where I can live watch. Hold on one second. Thank you. Okay, you see that the driver pod has been created, then it creating an executor pod. Basically in this case, what it is showing that my job is pretty much done because it was a very small job, and it kind of showing that how the pods get created. So I requested for one driver and one executor in this case. So it did create all these things, and it is done. And if I go back to the other terminal, the job is finished. I can actually do a Control-C. Now, if I just do the get pod for the default namespace, oh, sorry. And all the resources are gone because the job was finished. And just one thing. Because when I do get pod, it doesn't show any resource because there is no active resource. But if I do show all, I should be able to see just the driver pod. The reason Kubernetes didn't delete the driver pod because all my logs and everything is being stored in the driver pod. That is traditionally how also the Spark does. Now, if I want to see the output of the result of the pi and everything, what I could do is I can just say the same way we see the logs in the Docker. We should be able to see it over here. So you see the entire Spark log over here. I'm not going to the details. The important part is over here, which is the output. So, but there are various other ways you can also get the output. You can write the output to somewhere else. That is possible, and that's what probably you are going to do in most of the time. Now, going back to this Spark command, I just would like to highlight another piece which kind of I didn't cover while I was going through is this line. Because this is important. Now, Kubernetes is also about security and policies. So every time you run a job, you have to specify some kind of a responsible party's name. So in the Kubernetes world, it's called a service account. So I just created a service account under the namespace, and that service account is going to submit this job. Now, what is going to happen is, if my job needs to talk to HDFS, it will use that service account to get the right secrets. And right secret means basically whatever is mounted, whatever is available under the namespace. So it will get the right secret, and then it's going to use that secret to talk to HDFS. Now, talking to HDFS from a Spark, your code is not going to be different. Your code is going to remain same. It is just you need to plug your secrets, or in this case, key tabs. This is the way. So you need to have this service account name. Now, if you go to the Spark 2.3 Kubernetes webpage, everything that I did, at least in the context of the Spark, is very well documented, so you should be able to try. But I'm just going to give you maybe a few things that when you are going to run, say if you want to set up this in your local environment, which is like a desktop or a laptop, make sure that when you install the Docker in a basically a Docker registry, using a Docker, it is a little tricky to talk from a Vagrant VirtualBox VM back to the Docker. So, but you should be able to figure it out. Most of the times, you should be able to see that which port it is using. So when you run the Docker, you can run that Docker hub in such a way, specifying a particular IP and the port. Because you see that over here, when I'm passing this image, I basically ask the Docker to expose this particular IP. So don't use that the default one, which is host. Then it will become impossible for the Vagrant to talk to the Docker, because your Kubernetes is running inside a Vagrant, which is VirtualBox, and your Docker hub is running, in this case, inside a Docker. But if you want to run the Docker hub also in another Kubernetes pod, then it should be perfectly fine. Means you don't need to go through that pin. Having said that, we have, I think, around 12 minutes left. So I'd like to thank for attending my presentations, and I'd be happy to answer any questions. And if you don't mind, because these things are recorded, if you come and ask any question. Thank you.
Hello. Can you just talk more about how the secret works?
Okay, how the secret works?
Yeah.
Okay. So the way secret work is like the way in a Kubernetes you create any resource, you can create a secret. So there is a command called Coopctl create secrets, and you specify where your secret is or what is your secret. Or there is another way, which is the standard way. Any resource you create in Kubernetes is through an YAML. So you can create an YAML file, and there is a Coopctl command. You said that, okay, create this secret out of this YAML file. So your secret will be encrypted, and it will be base64 encoded, and it will be stored inside your namespace, where nobody else has access to it. Now, when you create a pod, you can tell the pod that, hey, mount this secret as a file. Like the way the way you mount anything in a Docker is pretty much the same way. And so even though your secret is a different kind of an object from a pod, whatever process or job that is running, they don't know anything about secret. They will think, oh, this is a directory and this is a file which is located over here, and I'm going to use the key tab as the same way I use a key tab. Normally, how people use key tab, when people do a kinit, you specify a key tab file name. So you are going to specify the same way. Your secret could be a key tab, or you can create multiple secrets. Actually, you can even store, sometimes I have seen people even store password or any other kind of files inside the secret. Anybody else? Yes.
Okay, so maybe you know the answer to this, or maybe I should talk to Spark devs, but is there anything on the roadmap to allow one to use, say, PySpark or Spark R on top of Kubernetes?
Yeah, I know that if you follow the Spark community, I think that it will be there pretty soon, because there is a lot of demands of PySpark, especially on the Spark ML community. See, I cannot speak on behalf of DataWorks because I don't work for them. But I'm just like you, a community member. I do contribute. But if I have to predict, not using my machine learning, but using my brain, probably it will be there pretty soon. Maybe the next release or something. Because I cannot see that the demand of using Spark in Kubernetes grows without having PySpark in place. Yeah, means I don't want to say it's, they said good. Any other questions? Kubernetes, Spark, Docker? Can I ask a question? Okay, let me ask you a question. How many of you are using currently Kubernetes or trying Kubernetes? Oh, that's great. Spark probably everybody is using. Okay, if we don't have any more questions, thank you again and enjoy the rest of the day.